And now you can start.
Okay. Well, we're almost coming to the end of Mission 89, so it's really, really exciting. I'm really happy today. I'm going to talk about the Engineering Center. And so, my name is Eleonore Poli, but for those who will be listening to the recording, I'm going to talk about the Engineering Center, what kind of facilities we have, so the internal design, the technologies that are necessary for the operation, possible resources needed, the organizational structure, which is basically how the astronauts inside are being managed and how to manage one another, with the different position profiles and duties, how they've been trained, what kind of YouTube videos you can find, the resources that they will need for a week, as in 5 days, guidelines provided to the facilities, protocols for both routine, safety, entertainment, food production, and 3D printing. A few technologies will be discussed about how you can implement this on Earth, and some guidelines that could be useful, and which kind of impacts for the Sustainable Development Goals, or SDGs, are being reached out with this kind of technologies and engineering center. If I'm talking too fast or not pronouncing, just scream, shout, let me know, and then I'll slow down and make sure that you understand what I say, and happy to answer any questions at the end. So to start with the engineering center, as part of the Habitat Marte, I've did this design on Google SketchUp. It's not amazing, but this is the ground floor. So this is a real 8 meters diameter. So this is up to scale. So this is up to scale. This is a very small rover, but it's to fit it in. But it's to give you an idea of how the habitat will really look like with proper dimensions. The ground floor would be the main engineering part of the habitat, okay? Here you have the airlock represented with both those red doors here. Here you have the rover storage. Here you have the EVA control center. And here you have everything that's about design, prototyping, 3D printing, and machinery. Google SketchUp does not have all the tools that you would have, so it's just representative. But the most important thing is the fume hoods. When you do 3D printing, there's lots of bad particles, toxic particles coming on, so you need those fume hoods. You would need to have lots of working spaces so that you can work on spacesuits repair, work on parts, work on new designs, discuss, etc., etc. So the surface here would take at least half of the base surface, because it would be extremely big, and there would be here would actually be storage. Storage would actually be much bigger than this, but to give you an idea, basically we would also need resources storage, tool storage, equipment storage, etc., etc. One very important thing I want to discuss is the airlock. Basically, the airlock would help to go outside, or also to connect to other bases. The airlock, the main thing is, if there's not a door here, and there's not a real good compartment here, you will have the pressurization of the base, and you'll have low oxygen, and you'll have dust coming in the base. So the airlock is a very, very crucial part. The air quantity in the base is also a crucial part, because we don't have that much oxygen in the Martian atmosphere. Obviously, you need to try to keep your air and recycle it and reuse it as much as you can. One way to do this is that when you do an EVA, instead of losing all this volume of air, you could get into your spacesuit, do the checkups, and you start depressurizing the airlock. This has two advantages. You remove the air here, which means you're not losing it by losing it when you open the door, but you store it inside in the rest of the base. And you also test the spacesuits before leaving. If there were to be any leaks, any holes in your spacesuits, you would see it right away, and you'd still be in the airlock, which means that it's like a maneuver of safety, right? You test them already, you already see if there's a problem, and if there's no problem, then you can go out. Airlock is also very important when somebody from another base wants to come in, right? So if this door is open, this door will not open. This is to keep the safety of the base together. You can see a little weird thing here, another here. This is a first aid kit, and this is a toilet. In the case of a leak, I'll be talking about this about the protocol later, but just so that you can show you a bit better here. In case of a leak or a compromise of the base, people should come in the airlock, okay, to stay safe. And in the first aid base, there would be any kits in case, I don't know, somebody fell, cut themselves, needed disinfectant, is sick, they would have this kit already ready, and obviously a bathroom would also help in case they are locked here for several hours. So this is basically why we have a toilet and a first aid kit. Now, if you go to the first floor, so you have the stairs coming up from this part here. So there would be the stairs, you can go back in. Here is just illustration that you would have the kitchen, you would have storage with a freezer here, you would have the vertical garden, and you would have gym equipment. The reason why I would have first the vertical garden, then the kitchen, then the gym is because if there's any fumes that are escaping from the 3D printing center, they would first go through the garden, then the kitchen, then the gym. So when you're doing exercise, the air would have been filtered to some extent because you also have fume hoods in the kitchen, which means that you're less likely to be breathing deeply while doing the gym and breathing some air that hasn't been filtrated and decontaminated. It's very simple. Here you have a monitor on the wall. This monitor would help in giving any, for example, the flight plan, but also any data on the temperature of the base, the oxygen levels, any kind of monitoring that you would like to have. In the gym, this is very illustrative, but there will be actually way more machines. There will be machines for cardio training and also strength training. And there would be a virtual coach that you can use with virtual trainings, which keep you fit and keep you focused and kind of give you a different kind of interaction. It would help you really achieve your goals, and there would be, you know, balls to play with, maybe mini basketball courts, or like kind of lines on the floor that could tell you, well, this is where you could play a game. It would really help in focusing on doing a good training and making sure. One of the most important, because you need astronauts to be rested, is the top. So again, you have the stairs coming in here, and this is the living room and music room. A music room is very important, I think, for people who are musicians, but also people who want to be creative. You need to be able to take this creativity out. Again, you would have a monitor on the wall that gives you temperature, any like schedule, any problems that you have, so it helps you getting any information that is critical. But at the same time, it's not looking at the sofa directly, so you can turn your attention away from it and try to relax, have some private time with your parents, or maybe listen to some music. There would be the bedroom storage, obviously would be adapted depending on how many astronauts you have in it. And there would be, here you can see some gas masks. The reason why you would have gas masks is because the time that you would take to go here, down the stairs, all the way to the airlock might be a bit too long if there's an oxygen leak. The gas mask would basically help you. They would have a rebreather, which means that most of your oxygen is being, your CO2 is being captured, and you're rebreathing your oxygen, which means that you can survive a few minutes with it. Okay, so this would be a safety so that if you have to escape, you can go down and then you can get to the airlock and you're fine. Obviously, you would have a bathroom with a shower, toilet, and mirror, anything that you need. The room will be quite spacey. The colors are a bit funky. The orange is to give something a bit more creative. The blue is actually because it's pacifying. Psychological research has shown that having some blue helps you being a bit more calm, will help people relax more and, you know, get the rest that they need. An addition that we could do is between beds is have some curtains, and these curtains will help people get a bit more intimacy. Depending on the number of astronauts, if you have only 4 astronauts, for example, you don't need bunk beds, or you could use the bunk beds as storage units. Now, let's go to the applied technologies. So the technologies, we need extra 3D printers. We need cutting tools. We need material to cut silicon wafers. For the silicon wafers being used, for example, for electronic systems, we need a white room. A white room is basically a room which has basically almost no contamination. And this is because we want to do electronic devices. We need the fume cupboards, as I explained before, basically 3D printing, and a lot of processes actually do expel a lot of particles that are dangerous on the long term. So we need basically this air to be pumped up and filtrated. The filtration process is quite easy, so it wouldn't be a very big setup needed, but they obviously need to be done. EVA communication room, again, I said we will need people that are responsible to make the communications. This is what the engineering center is about. A rover repair station and the airlock pressurization system. Other technologies that we might need is basically what to do with the water, the energy, air, and heat. Okay. In a normal base on Earth, you don't necessarily need to recycle the water, but when you're on Mars, you don't have that much water. You could try to extract some from the ice using, I'll send you the link after, basically what the hydration experience from MIT was doing, which is you drill the floor and you extract water from the ice and filtrate it. But one of the best ways to keep as much water as you can is to recycle the water from urine, cooking, and the garden. This water would be filtrated continuously, and the quality control will be made automatically. So on the control panel in the rooms, you would have water, quantity, and quality control. The air. So as said, we need fume hoods, we need a pump for the airlock, and basically we need a quality control of the air. Obviously, the air is also filtrated by the plants from the vertical garden, so it gives a little edge, but you also need obviously some detectors in every level, so you know exactly the good quality of it, and you need to check the pumps that they're still working and that there's no leaks. Energy, we mentioned this in some previous presentation. Basically on Mars, there's not that much atmosphere, so wind energy is a bit more critical to perform, although there are some technologies being developed to try and use it there. Solar panel, because of the sun position, because of the inclination, it might be difficult to get long and reliable solar energy. Therefore, if we want to go for sustainable, we have to go for geothermal energy, which means that we need to locate the base in certain locations. If we do not want to use sustainable energy, then some small nuclear reactors would be the best, at least fission reactors for the moment, and maybe later on fusion reactors. But it's quite unclear exactly which kind of technologies will be really 100% the best, the one being geothermal energy for the moment so that we don't have any waste. But to quite save some of this energy that we want to produce, one way would be to reuse the heat from human waste. Obviously, when you go to the toilet, your urine would go on one way. You don't need to use actually a toilet with water. You can just use a separator, a gravity separator. There's enough gravity on Mars, they would work. But you have the urine going one way and you have your human waste going the other way in another pipe. And basically in human waste, there's some bacteria that you can make react, and they produce methane, create heat. Normally, these bacteria need certain components to make it work. So feasibility would have to be completely discussed. But some centers do have these bacteria that emit this, CH4, so methane, and it would be a way for us to keep as much heat as we can in the base, as well as produce another way of creating energy. Fun way, and you can use human waste also for fertilizer for the vertical garden. Then the resources. So in Mars, we've found resources of aluminum, titanium, magnesium, silicon, iron. Silicon is actually quite present on the Earth's crust. It's actually one of the most present elements, and they are really critical for usually most of our constructions. But another one that is really important for our constructions normally is concrete, right? Concrete has been used in most developed countries now, and it's very cheap, very easy to do. But on Mars, you don't know if we have all the components, right? It's mainly calcium. I did check, and apparently you can replace some of the cement, some of the component cements with volcanic ash that you found on Mars. So it would be a way for us to build those critical buildings with some Martian-based cement. Obviously, there's also the research of 3D printing of Martian, dust, and we could try and make some useful habitats. For the moment, the mechanical properties are not extremely good, so we'd have to be probably bringing some of our own cement, some of our own aluminum or iron until we find real ores of those elements. One material that for sure won't be on Mars is wood, because even if we manage to have vertical gardens and stuff, you'll never grow a tree, or you will never grow a tree that quickly that you can use it. So for any reason, if we need wood, this is something that we will need to bring. And any petroleum-based products, I mean, they probably don't have any on Mars either. So if you want to create any plastic that is petroleum-based, then you will need to bring this from Earth. Again, you would have to assess why would you need wood? Why would you need a plastic bag? Surely we have enough of them on Earth and we don't need them. But for example, wood, I could see a psychological reason why it could be good to just touch wood to kind of create a connection back with Earth. And management, obviously, your base is not going to work if you don't have astronauts that are well trained and well managed. Depending on the number of people, this is the general structure, but you would need other people helping in this. But the main one is you need a commander, which is then responsible for overseeing the base engineer, the science officer, the communication officer, and the health officer. The commander would allocate a vice commander in case he or she is impaired. The base engineer would then get help from the science officer. The communication officer would probably help the science officer, and the health officer would have another representative. So there would probably be 2 or 3 people. The reason is because if one of the health officer is injured or dead or sick, they need somebody else to do the general check on people. Again, something we've discussed in the protocols. But what does a commander need? So the commander has a really critical role. When everything goes well, the commander doesn't have much to do, right? They check regularly on people and they take care of the mission, they take care of the crew. But most people are independent and work well enough that they will do the task every day. But if there's something critical happening, they need to take charge and they need to be able to lead, right? So they have to be in, a good harmony with the crew. They need to understand their crew, they need to understand their cultures and listen. They need to be proactive and organized. This is to help with the mission, right? So when you see that something is not working, you should be the first one to come and say, okay, there's a problem, we need to do this. And if there's danger, they need to make sure the whole crew comes out alive, or at least as much as they can, and they need to take urgent action and evacuate, right? They also are the ones that check the air and water quality, and they relay it to Mission Control Center. So to make sure that there's always communication. They also relay daily activities to Mission Control, and they make sure that we have a team debrief every day to solve any problems that might come out. Usually they have to have very good empathy, but they also need to be decisive. So you cannot be too emotional. You need to understand other people, but you need also to be in control of your emotion so that they don't get in your very strong and urgent decisions. As a base engineer, base engineer takes care basically of the base. So they take care of the pumps, they take care of the electronic systems, not communication, but what, just the kitchen or just the garden or just any electronic stuff. And they make a tour of the base and make sure that all the systems work. They provide periodical checks of the base integrity and all system, and they report to the whole team, not just the commander, they report to the whole team. This helps basically in being transparent and making sure that everything is working fine and there's no hidden problem, right? You have to be really proactive and say, look, there's a problem, and not just hide or not just tell one person, tell the whole crew and tell Mission Control Center so that they can repair any solution. Usually it's good to have a strong background in engineering, but also anything that is a bit simply technical, right? You could do engineering, but you could do theoretical engineering, and that won't be necessarily useful. And what's really important is that you have your hands-on, you know, that you have a practical mind, and that you can really learn quickly. And you also should receive a training on Earth, right? Normally when you repair the International Space Station, you don't repair it out of nowhere, right? There's somebody guiding you step by step, and you've received a training on Earth, and you can repair literally 100 different machines, okay? So this is the kind of training that the base engineer would need. Obviously, most astronauts would need to be able to repair some stuff, but the base engineer would be the one that can do it blindfolded, basically. The science officer. So the science officer would be the person responsible for all the scientific experiments going on at the engineering center. Some parts of the engineering center's duties would be to, for example, produce materials for scientific experiments or even conduct scientific experiments. One of them would be, for example, 3D printing of Martian dust, and you would have to document it. So the scientific officer would need a strong scientific multidisciplinary background. Maybe don't necessarily need a PhD, but they would need to have done quite some research and some research in different backgrounds. They would need to understand things, for example, in biology, in material science, in electronics, maybe psychology, and they would need to be there to check the progress of experiments, look after the devices, verify the protocols, and write the report. And they would also be the ones communicating using the reports and presentation. Usually the science officer would have a team of other people helping him with, or other astronauts would be working with them, but he would be overseeing basically most of the scientific parts. The communications officer, he or she should have a background in communication and computer technology. Normally it's quite useful. Well, it's a lot of expertise in radio waves, using walkie-talkies, using or rebooting computers, any kind of communication devices should be actually quite good at it. And they have an important staff which is responsible for communication checks with mission control centers and doing EVAs. If there's, for example, they would check talkie-walkies when you go out for an EVA, and they would make all the communication, and they would verify that all the computers also relay to the mission control center, etc., etc. Every morning, they would check the link checks with the whole base, not just engineering center, but the whole habitat Marte, and they would check also like communication with mission control centers, storage, backups. Obviously, you would have hard drives that save all the data and all the things happening on the habitat, right? Maybe like a sort of black box, and they would be responsible for this. Lastly, the health officer, background in medicine, I think almost would be necessary, and they would have a backup medical officer. So medical officer, they provide regular checks on the team's health. So every day they should monitor, like oxygen level, heart, talk with them shortly, maybe a 15 minutes conversation with each astronaut to just check, okay, psychologically, physically, how are you feeling? And they have to be on standby for EVA. So they have to be in the EVA communication room when there's an EVA, so that they can provide urgent help. So either by talkie-walkie, they can tell the person what to do, or they can bring them in the airlock. And once the airlock is repressurized, they can come in and then administer first aid. They will not only have a background in medicine, but they will receive specific first aid training and advanced medical training for extreme environment, because extreme environments sometimes have conditions that are very different than just, being on Earth and getting shot by a car. It's not necessarily the same kind of conditions that you would get on Mars. And Mars, it might be radiation exposure or like frostbite. Very kind of different medicine might be required. Now, the astronaut training program, obviously a lot of training would come before, but a lot of training would come during too. One of the most important ones is survival training. It's not just so that they would survive in case there's a problem with the base, it's also so that they get confident and they get a bit more tough, okay? You have to get used to being comfortable, you have to get used to doing more with less, okay? And survival training is a very important part of it. There will be a lot of team building and team psychology. Obviously, having a team that is very coherent, that works well together is extremely important. And for this, you also need the leadership training. Some people are natural leaders, some people are not, but they're not too far. And what they need simply is a training to understand that you cannot be a dictator, but you can lead strongly. You just need to be obviously a bit more empathy and like understand people better. Each astronaut would receive a science training. Why? Because they need also to perform experiments. So they need to understand what they're doing. They need to know how to use some equipment, not necessarily as well as the science officer, but they would still need the basic training. Same as the base engineering training, the communication training, and public speaking. Why? Because often you will have to relate to what is your daily life. You need to be able to talk to people and present well. If you talk like this and you say, oh, I don't know, I don't like Mars, or you're scared, then you're not sharing the mission well, and you're probably not contributing to helping fund the mission and attracting future astronauts. Another thing that could be interesting is cooking training. If you don't know how to cook and tomorrow you're supposed to cook for 5 people and you mess it up, they're going to be in a bad mood, right? So it's good to have basic cooking training. Most people know how to cook, but surprisingly some don't, and you prefer not learn this when you're on Mars. And obviously health and safety training. Everybody should be able to administer first aid, and actually even more. So when you're in space, you need more than just first aid training, but if you're in an analog space mission, usually first aid is sufficient. And evacuation, hygiene. So this is just the training programs. Obviously they would then have specific protocols. YouTube videos to train astronauts. I didn't put that many. I have an example of a workout, but I think because the main videos to train astronauts will be specific to the habitat. So you would have, for example, VR videos of the base to prepare astronauts. So you just put the helmet on them, and then they're like, they see how the base is and how to evacuate. They can look at psychological trainings and meditation videos. There's a bit of everything, and other videos they could use are, for example, videos to learn another language. If they have one of their team members that speak a different language, it can be a way for them to learn that language. But basically, training is too specific to give only like a few of YouTube videos. This is going to be up to the habitat later on. Resources needed for 5 days per person. So I gave the values for individuals between 70 kilos to 85 kilos, male and female. Obviously, male and female, we have different metabolism, we have different needs in protein, fats, iron, and usually oligo elements. Oxygen, this is more or less the value of a lung for 70 kilo male, but obviously that depends on your activity every day. So this is the needs for 5 days, 1,656 liters more or less. I think it's easier to run it up to 2,000, and water 20 liters more or less, and maximum of carbohydrates about 2 kilo per person, protein 1 kilo per person, fats half a kilo. Obviously, it depends on your metabolism. This was for people who are moderately active, because I think in the base, you will be moving a bit and you will also be doing sports every day. So you won't be doing 14 hours of sports per week, but you might do 1 hour of sport per day, which gives them base metabolism. Here's 2,800 calories. One thing that has to be really thought of is, depending on how much the vertical gardens give food and the greenhouses, we might not have that many fresh fruits and fresh vegetables. This can lead to vitamin C deficiency, and this can lead to scorbut. I haven't put how much vitamin C you need per day, but it is assumed here that we have enough fresh fruits. However, one thing that you will not have enough of is vitamin D. Vitamin D comes usually from exposure to the sun, and because we won't be in direct contact with sun, you will have vitamin D deficiency, and it means you have hair loss and your calcium can't attach to your bones anymore, and you feel really tired. In the UK, for example, they add vitamin D to a lot of products because there's not enough sunlight. So imagine on Mars. So this is something that is very easy. You just need pills, and this is something that would have to be put in the obviously reserves. If the mission is only 5 days, an analog mission, you don't need it. You have enough vitamin D in your body to survive. But if the mission were to be months long, then you would have this need of vitamin D. An example of just a 5-day menu. This is quite similar to the mission I had. You could have in the morning, for example, for breakfast, coconut and cranberry oats, and for snack, you could choose a fruit or some nuts, depending if your garden has produced any, a chickpea salad, a protein drink, pad thai in the evening, or you could have pancakes or peanut butter jam sandwich in the morning. And you can easily eat planted chicken. Planted chicken is the kind of chicken that's made from plants, as it says, and you can get all the protein you need. Then you can make linguine, pasta. All of these are actually really easy to do, easy to cook, take about 20 minutes. Really good, nutritious, and it's quite nice to have some variety. So this is an example of a menu you could have for a week. Now, guidelines to be provided to the facilities of the whole station. The main guideline you would have is simply when you visit the engineering center, you need to plan the visit and communicate it using the flight plan. So the mission control center would have to send demands saying, okay, you will have a visit from this base, and then the other astronauts in the engineering center, they know. And if the visit isn't announced, for example, there's an urgent problem, like some astronauts were outside of the base and they're the closest to the engineering center, one of them has a hole and a spacesuit that they can't repair, then you have to make contact via radio, and you need the go from the team to enter the airlock. If you try to get in the airlock and the other airlock door is not coming without this go. And once you enter the airlock, then there's the first aid kit is ready, so you can perform a quick medical assessment, also measure, for example, temperature, see if you have any diseases. For example, if you have to be urgently put in the base because you need for this before, right? So if you have any fever, you might contaminate other people or microbes on Mars, but you never know. So we humans might transport some of these bacteria, make sure that you don't compromise the rest of the people in the engineering center. Now, protocols. The routine protocols is daily health check of the crew, daily communication link check, daily base check, daily inventory and quality check, daily base cleaning, and team briefing in the morning and team debriefing in the evening. So as you see before, when I was talking about each astronaut's task, these are bits, each of them's tasks, except the base cleaning. The base cleaning is something that astronauts will have to do every day, and you can just change in this flight plan who does what to make sure it's all clean, decontaminated. The team briefing in the morning would be basically talking about the schedule, what you're going to do, and then the evening it's more how do you feel, is everything going well, etc., etc. And these protocols are just really kind of straightforward, easy, but they are very necessary in extreme environments. And the protocols for safety is basically you would have a fire alarm and you would have a base integrity alarm. The base integrity alarm basically says if there's, for example, a breach of the protective hull. So you might have radiation, you might have air that is blasting away, so you having a depressurization of the whole base, and these obviously you need to know right away. And if you in the top floor, you grab your gas mask, you make sure no one is there, you knock on the door of the toilet, make sure there's nobody in there, check again. Commander's rope, if the commander is in the ground floor, then they should not go up because they're going to put themselves at risk. There would be cameras that would help them know on the EVA if there's anyone still up there, and then they can see and try to talk by talkie-walkie with the base center what's happening. The airlock will have spacesuit too, and the first aid kit, so that some astronauts could go off. I haven't decided yet if you would have as many spacesuits as there are astronauts. I think that would be safe, but it depends obviously on the space available. And yeah, they usually would wait in the airlock until you have established, okay, well, it's safe to go out, it's not safe to go out. People from the main base are going to pick us up or not. Every day you would have a control of the air quality and of the radiation levels, and obviously you would know right away. And the food and water would also be checked every day. By checked, I mean that the foods you would check if there's any sign of rotting, any mold on it, because that also is a safety hazard. And you also check the inventory. Why? Because if you don't have food anymore, then obviously you have a problem, right? So every day you need to check this. This is obviously part of the usual inventory, but it's a very, very critical one. Protocols for occupancy and entertainment. So as you see, Olympic Games in Rio. Why did I put that image? Because one way that you can stay entertained is to do mini Olympic Games. As you know, lots of astronauts are not only very friendly, but they're also quite competitive. It's a very competitive job and you have to work really hard for it. So most of them have a competitive streak. And one way to get busy is to do mini Olympic Games. So, you know, like maybe what is your Olympic game? Maybe it's playing ping pong or lifting as much weight as you can, whatever it is, just something that, you know, you have to work toward this goal and you have to be a bit competitive, and you're still doing sports, which is really good for you, obviously. And it creates a bit of team spirit and the same as a friendly banter. There will be weekly movie nights. There will be wellness activities such as meditation and massage. Like you could also ask astronauts to train in massage giving can be very useful, or also massage themselves in case they have any injuries due to the trainings. Family time and external communication is obviously extremely important. And there will be library, music, and database, as well as educational resources. Some people love to get entertained with just, listening or reading, but other people like to learn more stuff. So that's why an educational resource is needed. And virtual reality sets. I think that one way to stay sane is to keep connected, for example, with nature, with what we know as humans. One way to do this would have those virtual reality sets, and you pretend that you're walking, for example, in the forest. Having contact with the garden, for example, touching the plants and smelling them is one way also that could be quite useful to keep connected with nature, or to keep yourself, just entertained. Now for sports, there are more and more programs such as Swift, where you can cycle or run in a virtual world that looks like the real world. And it's a way also for you to keep in it. For example, Team Peak, when he ran the London Marathon, he ran the London Marathon from space, and he saw where he was while running. Okay, so it's a way for humans to keep in touch. For food microproduction, I think the use of robots for monitoring plants as well as human is good. Why robots? Because robots can identify some different things than we do. So, for example, they can monitor any growth better than we can do. They can measure moisture, they can measure acidity, and they can, for example, do manipulation at night if needed. For humans, I think it's still good if we humans get in touch with the plants simply from a good mood and from, again, this contact thing point of view. If you can smell the plant, it's quite good. And if we focus on plants that need low water consumption, is quite useful. The reason why low water consumption could be useful is because if there's any problems with them, we don't lose them. We don't lose too much water. And at the same time is, for some reason, we have to evacuate the base for 10 days or 15 days, and we can't put them water, they will not necessarily die, right? You can leave that plant for a long time without taking care of it, and it will normally be okay. Interesting is to use herbs obviously for cooking, but also herbs that have a strong smell to stimulate senses and to make you feel more in contact with nature. There you see a picture of the Grobot hub that was used in the mission Igluna in Switzerland, and it's basically a robotic arm that is taking care of the vertical gardens. Regarding which kind of vertical garden is better, this is up to people who work in the greenhouse to decide. But I think, one that uses the least water could be one that is useful in case of evacuation. Protocols for 3D printing. First, make material inventory. Why? Because if you stop 3D printing something, you don't have enough material, then obviously you're screwed. You won't be able to do anything. The design must then be approved by the base engineer and the science officer together. Why the base engineer? Because sometimes those printing places, like those pieces that we need, are for the base itself. And if the science officer thinks the dimensions are like this and the base engineer knows they're not, then you have a problem if the science officer still printed the part. So it's a way to just make sure that you're redundant, that you're sure, you safe, the design is approved, okay, now we can print the part. Fume hose has to be turned on whenever you start printing. This is obviously to protect the operators, but to protect the whole base of the air. And also any progress on 3D printing of Martian soil must be sought and documented. So every time you attempt to 3D print some Martian soil, you really look at it and try to communicate to other people so you can improve it, because the day we can 3D print in a good way Martian soil is amazing, because it means we can start building out of it and we need to bring less material. Spin-offs. So what are the technologies that we can apply to Earth? We're thinking about climate change. We're thinking that we're going to have less and less drinkable water. We're going to have, more and more problems. And one way to rally is to use those water recycling facilities that you find, for example, on the International Space Station, and that you would find on Mars, to Earth. Okay, if each of our homes had water recycling facilities, we would need in general less water. Okay, we'd be using and digging less and pumping less water from natural reserves and just recycling our own water. Obviously, we need a very high quality control, but it works perfectly well on the ISS, so there's no reason we shouldn't work in our homes. Now, another thing we can do is improvement of heat management in buildings. If we see that the waste from humans can be really used for heat management quite easily on Mars, then there's absolutely no reason it shouldn't work on Earth. And we've seen that it works on Earth, so it's something that we could generalize, but usually also simply seeing, okay, well, is everything well insulated? We know it's a big problem that lots of houses are not well insulated, and simply changing this helps extremely well. The installation of vertical gardens, although it's something that we talk a lot in space, it's not something that we talk in homes, sadly. Obviously, we don't all have space to have a garden outside, but nobody asked about having a garden inside when actually makes a really big difference, and it's something I think should be really generalized. Regarding 3D printing, I don't think it's something that is needed. It's something that's becoming very popular and can be good, but it's not necessarily useful right now because people don't have the education to use those parts, know that they have the equipment to do this safely all the time. It's just not something that I would recommend. Guidelines to be applied to daily life. Respect one another, make quality work, and do more with less. Obviously, these are general terms, not necessarily to engineering center, but these are the things that I really think are important. And how do they impact the sustainable development goals? Well, you do affordable and clean energy, right? If you have geothermal energy, then it's clean energy, and it's something that is accessible and that we can, if we can develop it on Mars, then we can develop it on Earth without problem. Industry innovation infrastructure. Obviously, when we work on the 3D printing of Martian soils and just being independent, then we're obviously working a lot on innovation, and we're making sustainable environment, right? An engineering center which has its own energy production, its own 3D printing for the parts, and its own farming is obviously extremely sustainable, and it's something that I think would be really amazing to apply back on Earth. And obviously responsible consumption. When you're drinking your own pee, allegedly for treated pee, then you're being quite responsible, and it's something that I think is very, very important. In addition, you create new pieces and you repair rather than deliver, right? We won't have Amazon back on Mars, so we have to be careful and reuse, and you have to really think about how you take charge of tools and take care of them. And this is obviously something that we don't really think about when we're on Earth, but we will have to do on Mars, and something that we can apply back then to the SDGs. These are the references, so I will be sending you the presentation, but basically some are from NASA's solar radiation on Mars. It was to discuss basically the kind of energy that we might need, nuclear propulsion, settlements on Mars, powering of colony on Mars, and then there was toxicity risk of 3D printing, if you don't believe me, human waste bioreactor, oxygen, so this is half part, and basically Mars in general from 1992. As well as how can you promote concrete made from volcanic ash, which is something that you find on Mars. And if you need to contact me, these are my credentials. Add me on LinkedIn, Eleonore Poli. There's only one of me on this. On Instagram, HE Poli, and Twitter, Poli Eleonore. And if you can't pronounce my name, then just get my Instagram, then the rest should be fine. And I hope it was clear for all of you. Do let me know if you have any questions. And yeah. Hope you enjoyed it.